Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And guys, you are almost on the end of electrostatics. But anyway, this topic is independent of the rest of the topics, just as usual. But not as usual works in electrostatics. But yes, this electric dipole is independent of the rest of the topics. But that being said, you know what? Today we are going to get into a very interesting thing around electric dipole. If you haven't covered yesterday's lecture yet, please do cover it because you need a basic understanding of dipole, and that was given in last class, along with many model problems where you can do those model problems while you're attending the session or after the session, and probably get you got a question in 2019 from electric dipole just based on dipole moment calculation. It was all asked. But yes, today we are going to deal with something more interesting, little unrelated to what was taught in the last class, but the basic concept is going to remain the same. And that being said, students, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top ranking American university. I'm also an IIT who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications in India and abroad. And guys, yes, this was where we begin our discussion yesterday, saying that okay, there exists a dipole, there can be an oscillating dipole, and we did also talk about something known as the electromagnetic field around dipole. In such cases, where does your dipole lie? Dipole is something, the dipole exists over here. This arrow indicates the dipole moment's direction, and you can think about it as if this dipole is emitting some waves, and these waves are what waves? It can be both electric and magnetic waves. Today we are going to deal with more of this electric wave part of it. And if you remember, this was the magnetic field pattern along the z direction, having an oscillating dipole. All right. And that being said, the dipole was given by is expressed in terms of dipole moment. What is dipole, guys? Dipole is having two unlike charges with same magnitude separated by a small distance, in this case 2L. It's an electric dipole. So you have two charges, minus q and plus q, separated by a small distance 2L in this case. This is known as electric dipole, and symmetrically or unsymmetrical, not symmetrical. Alright, the charge distribution in a dipole is not symmetrical. And that being said, we define something known as dipole moment. And is dipole real? Yes, dipole exists. For an example, many of your organic and inorganic compounds exhibit dipole, and you can see those phenomena in your chemistry based problems as well. So yes, what is dipole, guys? Dipole is basically these two charges and forming a system. And what is dipole moment? Dipole moment is nothing but this magnitude of this charge multiplied with the length 2L. Okay, this is q multiplied with a length 2L. What is 2L? 2L is the distance between those two charges, right? And the unit was coulomb per meter. You know this thing, charge multiplied by some distance. And what was the significance of defining dipole moment? So electric dipole moment represents the strength of the electric field generated by the electric dipole. Strength of the electric field is denoted by the electric dipole moment. So if you remember this question, we discussed it yesterday. You can watch the complete lecture and maybe fast forward to the end and watch them. But we discussed this. Gauss law can't be used to calculate an electric field near dipole, because according to Gauss law, if you enclose a Gaussian surface, it's going to be zero. Charge enclosed is going to be zero, and it would say something like this, that the charge enclosed is zero. Hence, phi should be zero, since charge enclosed is zero. But this is not true in case of dipole. even though the charge enclosed is 0. The reason being, electric dipole do not have symmetrical charge distribution. So the answer was A. Okay. So that being said, guys, Ask Us Anything session is going to happen on 2nd of December at 9:30. Be sure to comment whatever you would like to learn about and whatever you would like to ask us about. So our JEE English team will be live at 9:30. All 4 of us will be coming on this channel at that time. And we are expecting that you guys would be coming up with all the queries. So make sure you are attending this event. Don't miss out this event, students. This event is specifically meant for you. And that being said, our team is also on Iconic subscription. You can take your JEE preparation to next level with personal coaches and JEE workshops from us, expert guidelines, and also our frequent test analysis and study planner. So this is the kind of thing that you get on Iconic subscription, and you can do that with JEE English team in exclusively and completely in English. So be sure to also share this channel. Do not forget to do that and like this channel, guys. And yeah, like this video, share this video with your friends on social media, because it's going to be a super interesting lecture. Not only that, someone in need may get access to this amazing lectures. And that being said, Unacademy Combat is going to happen again on 6th of December. Make sure you attend it and enroll right now with Murli live code. So what is this Unacademy Combat? As you know, it's the most competitive IIT JEE battle, and you can win lots of rewards and prizes. This includes Apple products, like many Apple products, hundreds of Amazon vouchers, hundreds of Amazon vouchers, and so don't miss it out. Enroll today. This is not just for your competition and for your prizes, but it's also for your JEE preparation. So yes, do enroll today and try to run the Unacademy Combat. So that being said, students, if you are not yet on our Telegram channel, do get on to our Telegram channel. First of all, download Telegram app from Google Play Store and App Store, and then click on to this link which is available in the description box below. Click on that arrow button on the left side of your mobile phone and just click on to this link. You will get on to our Telegram channel. Subscribe to our channel so that you can get before time notifications, on time updates on every class that is being conducted on JEE English and any lectures that our JEE English team conducts on your Telegram Unacademy learning app. And that being said, students, this Sunday from 10 a.m. to 1 p.m. we are going to have a problem and PYQ session on capacitors. A special class again, a free of cost special class again. Do not miss it out. It's from 10 a.m. to 1 p.m. We have covered already the A to Z series on capacitors. And I've already told you that you must be doing it hand in hand. Electrostatics and capacitors will go well hand in hand, especially the moment we started electrostatic potential. You could have done it, but anyway I've tried to take it from all together, keeping it independent of rest of the topics. But that being said, little bit of the concepts of current and electricity and electrostatics will come up in capacitor. Not a big deal, but you can still attend it. It's all it requires is only 6 lectures that you need to attend on Unacademy Learning app. So yes, you can attend them all on Unacademy Learning app. And this Sunday we are going to have problem and PYQ session. We'll be discussing different kind of model problems on a capacitor, which will give you a complete understanding of capacitor. Make sure you're attending it. Always you will be having a good understanding of capacitors by attending these sessions. And absolutely yeah, actually a good question. So how does rank booster sessions help you? Of course, rank booster session helps you guys. So try to attend rank booster session. Strategy session, rank booster sessions are really helpful for you. For understanding how you need to do and how you need to work around, what kind of syllabus you need to cover, and how are you going to prepare for your JEE Mains and JEE Advanced. Right, that being said, students, A to Z of units, dimensions, and measurements has already been completed on your Unacademy learning app. Definitely a no information. I mean, like KNOW, no information for you 2021 aspirants is that this is a topic for you to must do. Why do I say must do? Easiest scoring topic, where you typically get one question always in your JEE Mains. It's also less time consuming during your JEE Mains and JEE Advanced, and sometimes in JEE Advanced they come in a combination. So make sure you're attending this 4 back-to-back session along with the 5th model problem session, so that you can get the complete understanding of units, dimensions, and measurements. And guys, in this we have discussed unit-based problem, dimension analysis, measurement-based problem, least count analysis, error analysis, everything in 4 back-to-back free of cost session on your Unacademy learning app. So make sure you are attending this free sessions 4+1. Of course, do also complete one more session is there. Here only 4 sessions are mentioned. There is one model problem session, so different kind of model problems that were covered during the time. So make sure you attend them and you maintain completeness. Guys, maintain completeness. Don't attend just 2 sessions and leave the other 2 sessions. This is the biggest mistake that you can do in terms of any topic, except for the few topics like current, electricity, and magnetism, and a little bit of mechanics also there. But even in those, when you're preparing for JEE Advanced, completeness is the key. Completeness is the key, students. Okay, 2021 aspirants, don't ignore this topic. Definitely you get a question, and it's an easy one. It comes under the easy domain even during an exam, so do attend it and complete it. This is one of the mistakes that students make, that they ignore this only 1 mark. It's not 1 mark, guys, it's 4 marks. Okay. And yes, that being said, students, if you don't have Unacademy learning app yet, do download it from your Google Play Store and App Store. All you need to do is type in Unacademy on your Google Play Store and App Store, and the first search result will appear as Unacademy learning app, and just click onto this and click on this install button, the most downloaded education app. And guys, why do you need to have an Unacademy learning app? To attend these free of cost sessions, you need an Unacademy learning app, and also to attend Unacademy Combat and free of cost national level quizzes is what you get on Unacademy learning app. So make sure, guys, you have an Unacademy learning app handy, so that you can attend this special classes from anywhere. Not only that, you will get live notifications, up-to-date notifications, live notifications every time on your Unacademy learning app when a lecture is conducted by me, given that you follow me. Yeah, do follow me on Unacademy learning app, so that you can get updates on these sessions. And that means that even if you have a plus subscription, it's going to be very useful, since you can attend classes from anywhere. Not only that, guys, you can attend test series as well from anywhere once you purchase an Unacademy subscription and you have an Unacademy learning app. So yes, if you're looking for the best in class program and the best in class platform and the best in class, the classes for your JEE preparation, it's going to be Unacademy subscription. Guys, what do I mean by the best in class program, the best in class platform, the best in class program? I'm talking about Unacademy subscription program, which comes with the best educators across the nation on a single platform. And guys, not only that, it's going to be a best program, a structured program in which you will undergo an extensive and intensive training for your JEE Mains and JEE Advanced preparation. It's a champions tool for your JEE Mains and JEE Advanced preparation. You need not worry about anything. Everything will be taken care on Unacademy subscription platform. This includes daily interactive classes with the best educators across the nation, and as well as, dedicated doubt clearing sessions on each topic. For an example, every 4th session is going to be a doubt clearing session, national level test series, and yes, you get to understand your standing and you get to assess a lot of things, and a very interactive platform where you enjoy learning. So this is the kind of thing that you get on Unacademy subscription platform. All you need to do is click on the left hand top corner extension bar, choose plus, choose IIT JEE as your goal, and guys, with this you are preparing for both JEE Mains and JEE Advanced, and then hit on this get subscription button. And what you get with this get subscription button, you get unlimited access throughout the period. You can attend as many programs as you want. And that being said, students, this all comes at a price of less than 70 rupees a day. All you have to pay is 70 rupees a day to attend Unacademy subscription, guys, to attend programs on Unacademy subscription with the best educators across the nation. So yes, all it costs is 70 rupees, and this is for a 24-month package, guys. This is typically meant for 8th class students, 9th class students, 10th class students, and 11th class students. And students, do not forget to apply Murli Live coupon to avail the best discount or to get to this price point. Yes, don't miss out the best discount on your subscription purchase. Make sure you apply them. And that being said, students, you can split your payments into multiple parts. You can pay them into multiple parts. Using these two interesting payment options, one is going to be pay in parts, our in-house feature, and the other one is going to be a no-cost EMI. So yes, we also do have no-cost EMI where you don't have to go through the burden of paying all the fee at once. So you can split your payments into multiple parts. You don't have to pay them all at once on an Academy subscription platform. So if you're looking for one such option, yeah, do check it out. If you're looking for debit card, credit card, UPIs, we have them as well. And that being said, students, if you are a long-term or a dropper, a 12-month program is for you. Why is that for you? We have dedicated droppers batch and dedicated individual programs going on for your JEE Mains and JEE Advanced preparation. Yes, students, we have dedicated programs going on for your JEE Mains and JEE Advanced preparation. We have droppers batch. We have 6,000 plus materials. We have 1,000 plus live programs going on for your JEE Mains and JEE Advanced preparation, an ideal program for droppers. And students, how much does this cost you? Less than 2,900 is what you have to pay for your Unacademy subscription. And do not forget to apply Murli Live coupon to get the best discount on your subscription purchase. Yes, apply Murli Live coupon on any of your subscription purchases, but yes, don't miss it out. And that being said, if you're looking for personal coaches, and that too like a personal coaching from IITians and NITians who can lay down the roadmap for you to crack IIT JEE and IIT JEE Mains or IIT JEE Advanced, it's going to be on Unacademy Iconic subscription. If you check it out, there will be two kinds of subscription. One would be a plus subscription, one would be an Iconic subscription. If you choose Iconic subscription, what you additionally get is like the IITians and NITians who will be guiding you in real time on how to work around your exam. You will get personal coaching from them, motivation sessions from them, you will be getting expert analysis from them, you will be getting guidelines from them, you will be getting also study planner, personalized study plan. And students, this all comes at a price of 50,400 if you go for a 12-month subscription, and if you go for a 24-month subscription, it's going to cost you 77,400. And do not forget to apply Murli Live coupon to get the best discount on your subscription purchase. If you want to avail the best discount, make sure you are applying Murli Live coupon on any of your subscription purchases. But that being said, students, Iconic subscription prices are going to be hiked from 30th of November. So make sure you are availing it before 30th of November. If you are doing so, you will be saving a lot of money. If you check it out, the 12-month subscription is going to be like, anywhere around 65,000, and your 24-month subscription is going to cost you a lakh. But if you do it right now, it's definitely a lot cheaper than what it would be. So that being said, practice and practice and practice makes human perfect. This chapter we have something even more interesting for you, that is going to be electric dipole, where you need to first of all understand the concept and then practice around it. So make sure you are practicing well when it comes to electrostatics. Yeah, do get started with this question. So this kind of question is what you can expect. A dipole moment of a system would be given to you, maybe in terms of numbers or maybe in terms of just P, something like that, with a variable, and they will ask you to find out electric field. Okay, we'll be starting out with a basic problem, then we'll be moving into a little advanced problem, and we'll be understanding everything around it. So stay attentive, and students, do not forget to share this video, do not forget to like this video, Make sure you are asking your friends also to attend the session, and more importantly guys, share it on your social media, share it on your Facebook, share it on your WhatsApp, share it on your Telegram channel, so that students in need may get access to this amazing session. All right, let's get into this problem. So this question says, so everything in dipole, first of all, there is something that you need to know. We discussed two things yesterday. One was dipole axis, which is on the line of charges. The other one is something that is perpendicular to the charges, that is going to be like equatorial axis. So first of all, do understand that the equatorial axis and dipole axis meet at a point known as dipole center. Right, so there is a dipole center, and always your kind of measurements or your distances from the dipole system, electric dipole system, is given in terms of like the distance from the dipole center. All right, any kind of distance with some inclination or without some inclination, etc. We'll move into this chapter and we'll understand it. First of all, read what is being asked in this question. Like the electric field at a point A, which is at a distance x, from the dipole center. The electric field due to the dipole system at a point A, which is at a distance x from the dipole, and also told to you, even though it may not appear to the scale, it is just for your understanding that I'm giving you a dipole. Sometimes dipole will just be represented with an arrow. So yep, make sure you're making use of all of these conventions. Taking down notes is also very important, students, during electrostatics, or beat any other lecture series, but especially during electrostatics, it's going to be very useful. Alright, and given here is x is greater than 2L, which is the distance between dipole. Okay, what are the things that are given to you in the option? Look at the option carefully and assess the thing. First of all, let me complete this. This is dipole center. That is what I discussed, but I didn't write it down. So let me complete this point. So yeah, that being said, what is given to you in options? In options, you can see P, and P. The electric field has to be assessed in terms of dipole moment. What is dipole moment? Not necessary, but during this question, yes, it's necessary. And how does the dipole moment move? What is it? It's a vectorial quantity. It moves from negative to positive. In the pair, it moves from negative to positive. Alright, get started, guys. It's your time to get started. We have already discussed dipole moment. Just do the normal math. You will come to some conclusion. Of course, there is an approximation in this problem. So do the approximation as well. Write it on your own. All right, let's get started then. So guys, how do you work around this problem? Very important concept. Throughout this this session, we are going to deal with dipole based concepts. Don't ignore them, they can be a part in your exam. Okay, simply we need to assess electric field at this point. Just think about it that way, that you need to assess electric field at this point. Right, so this is what you need to do at this point A. So let's do a thing. Okay, let's not look at it as if it is a dipole system initially. Finally, you need to do that. I'm going to say this is how much. This is distance. This is what is this distance, guys? This is the distance between the positive charge and this point A over here, right? And how much is this distance? This is 2L. From dipole center, the distance is x. Then how much is this distance? This is from dipole center, distance between the dipole center and positive charge is L. Dipole center to negative charge, the distance is L. It's L and L. So that's the reason we took it as 2L. If any of you had any any queries in your mind that why didn't we take it as D and rather we took it as 2L, because the calculations become easy, you can still take it as D and work around and you'll get the same thing. All right. So if this is L and this is X, what is this distance? This is X minus of L. Okay, let's call this point as R1 for this guy. This distance is R1, this vector is R1, etc. And now I'm going to, of course, as you know, get to the negative charge. This negative charge is at a distance, how much? You need to add half the distance of separation, because since X from the dipole center, this is going to be, this L should be added. It's going to be X plus of L. Okay. And let's do a thing. I'm going to give it a name like R2. Can we say something like this? This at this point it is nearer to positive charge, hence your net electric field should be positive. Okay, if we assume this to be like an x-axis and a y-axis, what you can do is, okay, temporarily assume it has to be x-axis and y-axis. Let's say this is, dipole moment is a vector quantity, it's not a scalar quantity, and the electric field should be in the direction of dipole. For like an axial point, for a point on its dipole axis, the dipole moment and electric field will be in the same direction given that it lies on the positive charge side. Okay, hence A cannot be right and C cannot be right. It's nearer to positive charge, hence this should be true, isn't it? Alright, now let's do a thing. So how do we calculate this electric field? Electric field at this point A can be said something like this. Forget the dipole moment. Let's give it a name like this: K into Q plus Q divided by X minus L whole square minus of Y minus minus Q. Okay, opposite direction. K into Q into K into Q into X plus of L whole square. Right? So you need to simplify this. It's basically, if you have any confusion, I wrote down R1 and R2. So this is R1 square minus negative charges at a distance R2. Okay, R2 square. Simplify this and you will get some interesting result. Let's do a thing. Let's start simplifying this. I'm just simplifying this part. Okay. So simplifying that equation, electric field at point A is going to be K and Q can be taken out as common. In the earlier one, it would be 1 divided by X minus L whole square minus of 1 divided by X plus L whole square. This is quite simple, guys. Just focus. If I'm going to multiply this both terms, of course I need to finally get a combined term. I'm going to multiply this both terms on the denominator. What is the thing that I'm getting? This X minus L into X plus L. We can write it down something like this. Can we? Take out a square common. So this would be like X minus L into X plus L whole square. X plus L whole square minus of X minus L whole square. We got this amazing equation here. Let's do a small math, possibly here itself. or probably on the next page. But before that, let me just show you a small thing. So can we write this down as x minus L into x plus L as x square minus L square a minus b into a plus b. So this, I'm just writing it down, just the simplification over here. So this thing could appear as x square minus L square whole square. How about on the numerator? Expand this, you will get x square plus L square plus 2xl minus of x square plus L square minus 2xl, right? So x square, L square would get cancelled out. What would be remaining is 4xl. That is it, isn't it? On the numerator, 4xl would be left, and on the denominator, some x square minus L square whole square will be there. Now the thing is, observe one thing, we are always denoting it as vector. And by intuition, we know these both charges have same magnitude. This is a lot away from minus charge. It's a lot away from minus q charge. Hence, the field should be in the direction. This is the dipole moment action, right? Negative to positive. Your dipole direction should be the field's direction. I'm going to define something known as P cap. Does not matter. At the end of the day, we are going to write it down in terms of P. Hi. Focus, students, focus. It's a simple math-based question anymore. It's not, nothing is left over. So yeah, remember this P cap. Everywhere there was a P cap. I'm just introducing this P cap now so that you understand it better. So let's move on now. Okay. Now what do we have? Electric field, if you remember from the last equation, it can be written as B add something like 4xl on the numerator. So this would become k into q into 4 into x into L, divided by x square minus L square whole square. Now here comes the twist in this game. Okay, I told you in the beginning this is not up to the scale, and it was already given in the question that x is greater than L, right? That means, can we say something like this? X square minus L square is approximately equal to x square. We'll do this often in physics, guys, because L might be something in few like micrometers, etc., and x might be in meters. Hence, you can simply ignore the L square term. But if you are wondering why didn't we do it in the initial case itself, we are trying to derive for dipole. Alright, so that is the process. That's a process to go around. Don't worry about it. That is how it works. Alright, so we are going to do this. This approximation is something that we will often keep doing. So if I am going to approximate this term, it's going to be written as x square whole square instead of x square minus L square. So this can be approximated something like this. And k would remain, k is a constant term, and there remains two other terms. Here this is an L, actually this does not look like an L, and here if you notice this is q into L, and from this what is P? Magnitude of P is how much? P is q into 2L, right? This is dipole magnitude, right? Dipole value, right? Magnitude of charge multiplied by twice the length. That is it. Just write it down, and you will get this to be like 4 into x into q into L. Okay. Now what I'm going to do is I have to further approximate nothing but understand something, that there is a P cap associated with it. P cap associated with it all the time. So now we need to anyway but further express it in terms of P as you understood it. But anyway, 1x and 1 over here that will be x to the power 4, and 1x would get cancelled. So you would have something like x cube. Okay, you would have something like x cube. Now on the numerator, if I push this q and l together and multiply that with a 2 from the 4, 1 2 would be remaining. This can be called as p, isn't it? If I take a 2 into this and say that this is nothing but p, right? So this would be 2k into 2ql. What is it? P cap. What is this? 2k into p divided by x cube into p cap. Everything is fine? Absolutely. Alright. So finally, we can define something like this. Electric field at point A all along with direction as a vectorial quantity can be written as k into p into twice of the k into p divided by x cube into what? P cap. But instead, can I denote something like this? Because p of p cap is basically p vector. That is it. That is it, guys. So this is the electric field at a point on the axis of the dipole to the right. Okay, it is to the right. I believe you understood this point. Let me quickly highlight this. Why did I say to the right, to the left? What would be the change? Okay, anyway, first of all, this is a standardized term, students. This is a standardized term. Before I proceed to the answer, just note it down. This is electric field of a dipole or electric field due to an electric dipole on its dipole axis. On its dipole axis. Why am I being very specific about this dipole axis? You'll understand that point. Note it down. So the answer should have been between B and D, and we know the answer is D. Okay, easy. Alright, let's move on to the next problem. Next problem says the same thing, but x distance from the dipole center, but on the left side. On the left hand side. Alright, now we need to think about it little with caution that what would happen. So let me tell you, it's nearer to negative charge. It's on the dipole axis again. If you notice this is all on the dipole axis. So we know it should be something negative. It cannot be positive. Of course, you can use method of elimination, eliminate C and D, but this is something that you need to understand, guys. Okay, and this x distance is considerably larger than your dipole distance, separation between the separation distance between dipole. Now let me tell you something. Maybe electric field is in the opposite direction to that of dipole. So let me do something like this. Electric field should be in this direction, right? So can I simply, I know still we need to do the calculation, etc., But just from your sort of intuition, can you guess this? Something like this? All right, yeah, I got your point. So your electric field should be how much? It should be in the opposite direction of the dipole moment, because dipole moment goes from negative to positive. The same term I'm going to write it down. Just do a small thing, add a negative sign to it and divide it by x cube. And there should be a 2, of course. It's on the axis. It's the same term, right? There is no difference. I've just added a negative sign. Guys, this would work. Why not? We are assessing everything in terms of dipole moment. This should work. Isn't it? Yes or no? Actually, no. This is not how it works. So this is nearer to negative charge, but your electric field is going to be in this direction. Because here negative charge attracts, let me do a thing. Let me give them the color, and this would be clearer, because this is what we think generally. It should be, it's nearer to negative charge, and so it should be negative. No, not necessary. We are not we have not yet started about some other quantity. There you would see something like this. So in this case, electric field due to minus q charge is going to be in this direction, and due to positive charge it's going to be in this direction. Which is greater? Of course, minus q is greater. So electric field is ultimately going to be in the dipole's direction. Hence, it would not be negative, just be positive. I've intentionally got these options where I kept it as negative, but you know what? It should be positive. There's no way it's to be negative. Anyway, we are assessing magnitude in this case. This is just for your understanding. Just because I told you dipole moment near positive charge should be in the direction of dipole moment does not mean it's going to be in the opposite direction of dipole moment once we are near the negative charge. Makes sense? Because your axis, we are assuming the axis to be something like this. Don't make that mistake, that's it. Alright, I believe this is clear, because some of you must have had it out. Alright, they're saying it's going to be near on the side of positive charge, it should be in the direction of dipole. Then near the negative charge, on the other side of the negative charge, it should be in the opposite direction. Absolutely no. Okay, with this, okay, first of all, what did we derive on? This is for axis. We are going to discuss about the electric field on the axis of the dipole, and in this case we are not concerned about the distance, what is happening between the distance between that of dipole. Okay, and from this, if I'm going to draw an axis like this, x and y, your dipole is somewhere, dipole moment I mean, is in the positive x direction. Let me do a thing. Let me quickly change this thing. But we are only talking with respect to x, so we need not even need to know about the y-axis, just for understanding, because as soon as we move to the next question, it will be useful. Okay, this is the dipole's direction along x, positive x. Electric field, if you remember, was always also along positive x. So okay, this is the x and this is negative x. The distance between dipole is very small. Let me do a thing. Let me change the color. Quickly I'll change the color because it will be better for understanding. So if you remember, we are concerned about just the distances away from the dipole. In fact, x is larger than that of the separation between dipole. We are not going to anyway talk about what is happening in the distance between that of dipole or the between the separation of dipole. What is happening? We are not actually concerned about it at all. Okay. So as you understood, we are going to do something like this. But what if you have arranged the dipole in the reverse direction? Still the electric field is in the direction of dipole. Still the electric field is in the direction of dipole moment, whatever. Both are in the same direction. And what is the direction in this case? It's along positive x. Right, so this is x, this is electric field of from dipole with x. How it is changing? That's the question. But before that, let me quickly recall something. We wrote electric field is equal to 2k into p divided by x cube. That means with increase in distance, electric field should fall. Obviously, right? Like this. Approach near infinity, 0. And for the left hand side, what is going to happen? Still the electric field is going to be positive, max near the charge. This is on 1 by x cube graph. This is like y is proportional to 1 by x cube graph. This is exactly not how it would look like, but something like this. Simple. What is the conclusion? Conclusion is that electric field, irrespective of the side, of the side of the dipole, is going to be, irrespective of the side of the what do we mean by side is, I hope you understand, negative x or positive x. The dipole moment on the dipole axis is going to be the dipole's direction. Dipole moment on the dipole axis, is in the direction of electric field, or electric field rather I should have said is in the direction of dipole. Okay, write it down the other way around while you are writing it down. Same direction, okay. Electric field and dipole moment have same direction, basically. That's what I meant. That is it. We have just proved that point and you understood it. But anyway, let's move on to the next question. So this is the graph, and a very important thing, if you remember, for electric field for a point charge, it was with distance, how it was reducing x square, but on dipole axis, this is specifically for dipole axis, right? Because we'll understand that point, this is specifically for dipole axis. Okay, if you move on some other place, it will entirely change. This is just for dipole axis. Just a moment, guys. This is just for dipole axis. Don't get your counterintuitive thought and you'll miss it out. Yeah, that is it. And how does the electric field reduce? Not 1 by r square, but 1 by r cube. If I'm going to call this instead of x as r, if you remember, it was k cube by r square, but here p is constant. In this term, p is constant. Alright, now let's move on to a very interesting question. Okay, the electric potential at a point A on dipole axis due to the shown dipole system. Now we are talking about Same kind of dipole system. Dipole system, this on all of the questions is going to remain the same depending upon which kind of okay, but generally it's 1q and plus q, negative q and positive q. Maybe little complicated. You know what to do. You need to assess electric field individually due to each dipole system and calculate them. Vectorially add them. Everything will come up in terms of dipole. But now we are going to talk about electric potential. Think about it carefully. On a point on the axis which is at a distance x away from the center, same as the initial case. Now they are asking at the same point, what is the electric potential? Try it out yourself. You need to think about it. Think about it, think about it, think about it, think about it, and get started. If you think little carefully, you'll get the answer. Put your pen on the paper, students. Put your pen on the paper and do not forget to share the video. Put your pen on the paper. Very important, right? You don't put your pen on the paper, it'll go off the track or it'll go on the top of your head, something like that. All right, let's get started then. So we are getting started with electric potential. So we need to assess electric potential at this point, as usual, just like how we did earlier. How much is this distance? X minus, this is L from dipole center, this is at distance x. So this is going to be x minus that of L. And what about this? This is going to be x plus that of L. This is all clear. And you need not even be worrying about R, etc. Let me temporarily call this as R1 and this as R2. What is the electric potential? Electric potential net would be one due to your negative charge and the other one due to your positive charge. Now add them up. If I'm going to add them up, this is going to be minus of kq divided by R2 or R1, because this has been given R2, and plus of kq, this is due to this plus charge at a distance x on a point A, which is at a distance x from the dipole center, divided by R2. That is it. If you simplify this further, substitute the value of R1 and R2. Okay, let me do it on the next one. But what I'm going to do is I'm going to substitute the value of R1 and R2 on the next page. So make sure you're taking down the notes, students. Alright. So that being said, B net is equal to, we had something like KQ divided by R2, which is X minus of L, minus of negative minus of kq x plus L, right? This was x plus L. Now again those interesting terms will come up. If you remember, just take out kq common and x minus L into x plus L, what does it give you? Let me keep it this way. X plus L minus of x minus of x. It's something like positive k into k. Let's simplify this further. Write it down, take down the notes, very important. This is anyway like the derivation part, but do it at least once in a while. You should be doing this kind of derivations, be it JEE, even your JEE Mains aspirant or even advanced aspirant understand the importance of derivation, where you get question all of a sudden around the concept, and there you don't want to struggle. Mains students, don't do that mistake. It will be very helpful for your understanding of the concepts. So very important. This is 2L. That's it. On the denominator, what do we have? X minus L into X plus L. That is going to be X square minus L square. And I'm not going to write it down as X square minus L square. Rather, I should have been writing it down as X square Y. The same reason, guys. It's approximately equal to X square because X is greater than that of L. Okay, so what did you get? K into Q into 2L. I'm just going to leave that term. 1 by X square instead of X square minus L square. So approximately, but the same thing because X is greater than that of L. And post that I'm going to write 2QL. What is this? Magnitude of dipole moment. Is that it? Alright. So this could have been written instead as K into P divided by X square. K into P divided by X square. Magnitude of P on this time, not vector P. This is the net potential, students. This is the net potential on a point on the axis to the right. Given the dipole system is like this. Okay, given the dipole system, it totally depends upon the dipole system. I'll tell you why. Okay. Now we wrote E net. Sorry, I'm really sorry, guys. So it should have been V net. V net total or V net due to the dipole system or VP. Generally, sometimes it's called as VP. So I'm going to write it down as VP is equal to how much? K into P divided by X square. Done. That is it, guys. That is it. That is it. That is all you need to know. This is the potential at a point on the axis. On the dipole axis due to the dipole system. Okay, it's on the dipole axis. There is also equatorial axis. Simple. What did you notice? Dipole's potential is dropping with X square. There it was X cube. Of course, there should be like a reduction in X in terms of. Simple? Alright. Now comes an interesting question. The electric potential at a point A on the dipole axis due to the shown dipole system, which is at a distance x from the dipole center. This time it's lying on the negative charge side. But if you remember, for the electric field, we said that it's always going to be in this direction. Does that mean V net is going to be K into P? You need to remember this, guys, divided by X square. What do you think? It should be right? Electric field was also positive, potential should also be positive. Isn't that true, students? No. Right? Nearer to negative charge, electric potential will be more negative. It was just due to that sign convention and the direction of the field you got it that way. But now we are talking about a potential, a scalar quantity. So this is the one of the classic example where the vector quantity is still positive, but the scalar quantity has become a negative. Often these questions are being asked like, can a scalar quantity be negative? Yeah, they can be negative. Now let's check it out whether what I'm saying is correct. Because it's best to have kind of a confirmation. This is L, this is X, this should be X minus L. And how about the positive charge is at a distance? X plus L. This time I'm not going to write down R1 and R2, directly write it down. So check out the V net is going to be one due to V negative, other due to V positive, and then just add it up. Due to negative, what it is going to be? KQ minus KQ divided by X minus L, minus or plus of K into Q divided by X plus L. Simple. Now further simplify it, you'll be getting something like K into Q divided by 1 by X plus L minus of 1 by X minus L. This is a larger or a smaller quantity. Now the denominator is a larger quantity, hence this entire term is going to be a small quantity. Ultimately, it has to be negative. Okay. Confirmation number one. Confirmation point number one. Let's check it out. Now I'm going to further write down this equation. So this is going to be K into Q divided by K into Q into 1 divided by X plus L minus of 1 divided by X minus L. Here I am going to just take the common denominator, and that means numerator has to be also changed. It cannot be 1 anymore. So if you remember, this will be what? Carried on this side, X minus L. This will be carried on this side, just so that you understand this concept well, but I know many of you know this math. X minus L minus of X plus L. Minus of X plus L. Is that what we said? It's not about direction, it's just about magnitude. P here is just Q into L, isn't it? XX anyway would get cancelled as usual. What would you have? K into this entire term would become minus 2L, right? It would be minus 2L. So this should be minus of, or I should have written as K into minus of P. I was about to write that, but since you understood that Q into 2L is how much? P. So I'm going to say this is minus of K into P divided by this A plus B minus of A minus B, the same thing. And further, this can be approximated to minus K into P divided by X square, because X square minus L square is going to be X. Did you notice something amazing? Now at this point, before we proceed into this entire thing, let me rewrite it. Potential on the negative charge side was how much? Minus K into P. P is a positive quantity. Don't we have something amazing here? Yes. Let's do a thing. Let's draw a graph and see whether this is really amazing or not. So, but anyway, if you remember, the potential is varying with 1 by X square. But let's write down the equation that would be more, understandable in this case. This is what your axis is. This is your potential. This is your X. X on what? X on your dipole axis. This is your X. Okay. This is of course going to be a minus X. Now let's do a thing. Let's draw the graph. I think this is going to be very interesting if you notice it. So on this side, what was the equation? Equation was, due to dipole, it was K into P divided by X square. Okay. On this side, what is happening is going to maximum near about at a lesser distance. It's going to be more. You can't say maximum at this point or minimum at this point. going to be actually minimum near the dipole and maximum is for positive one, isn't it? Yeah. So yeah, it's going to be minimum and it's going to increase as you move away from the dipole. This is for this dipole system. If you just turn this dipole system positive on the left side and negative on the right side, what is going to happen? Negative is going to become negative potential. You have a graph like this. So y is proportional to 1 by x square and 1 minus 1 by x square. This is y is proportional to 1 by x square graph, whereas other one on the third quadrant is going to be y is proportional to minus 1 by x square graph. A very important point to note: electric field direction is going to remain the same. Magnitude, it's just it will become a positive thing, whereas in electric potential, what is happening? One side it's negative, other side it's positive. Alright, now comes the most interesting part of this discussion. So, electric field at a point on the equatorial axis due to the shown dipole system, which is at a distance x from the dipole center. Now it's on the equatorial axis, it's no more on the dipole axis. Take your time, there is a simple way. Yesterday we did a very similar problem. I mean, we didn't do it for, we didn't do it for electric field, but we did it for dipole. Dipole moment is also a vector quantity, right? Net dipole moment of the system. Now think about it. Get started. There is a simple way of solving this problem. Everything over here is relative to the dipole vector. Okay. It's like the dipole vector is dipole moment vector, or dipole vector is the thing that we are considering. Alright, let's move into this question. I believe some of you must have understood it. So first of all, let me do a thing. Let's define, due to this negative and positive charge, it's going to be towards the negative charge. Okay, but if you have noticed one thing, both are at the same distance. If I'm going to draw this distance from this negative charge, it's going to be how much? I'm going to call this as r. This is also r. Why? This is x, this is L, this is a right angle triangle. R is how much? Under root of x square plus L square. Okay, r is going to be under root of x square plus L square. Now let's get into the point of electric field due to the positive one. Positive one, it's going to be like this. So magnitude of electric field due to positive and negative are the same, pretty much the same. But if you resolve the component, one component of this positive, let's give this name like an E positive, one is going to be like this and the other is going to be like this. This is E positive in the x direction, you can say, or in the dipole's direction, and you can say this is E perpendicular in the dipole's direction, positive. How about due to negative? Do remember, magnitude is the same. Due to negative, it's going to come down like this. Okay. It's going to come down like this. That is the perpendicular component. What about horizontal, or the direction of dipole? Going to be of the same magnitude anyway. This is messing up, just a moment guys. So it's going to be in the same direction of the dipole, E negative. They are of the same magnitude, if you understood it. So this time let me pose this question, that what is the dipole moment's direction, guys? Dipole's moment's direction is going to be from negative to positive, positive to negative, positive to negative, or negative to positive, negative to positive, negative to positive. Again, dipole's direction is from negative to positive. So dipole's direction, so if you define like two things, let me just quickly have a look at it. So one more thing I would like to say is this thing and this thing would get cancelled out, right? So on the equatorial axis, it's on the equatorial axis, right? That's when this is possible. On the equatorial axis, what have you observed? You observed that the dipole moment has a negative direction to that of its electric field. Okay, electric field, I'm just denoting net electric field, a unit vector with E net cap, and dipole the P cap. So both are in the opposite directions. Interesting conclusion, no? Because now see, I've just twisted the charge arrangement so that you understand it really well. Dipole moment's direction is like this, electric field's direction. The dipole moment's direction was like this, and the electric field's direction was also like this. Let's now get into the problem. That is where we are stuck right now, right? So it's a very simple problem. You know, these components are cancelled out. Let me do a quick thing. Let's move on to the next page. I don't need to write down the perpendicular component. I'm only going to write down the electric field in the dipole direction, but it's actually in the opposite direction. Okay. All right. So we have something like this, and you know this should be it. Okay, this is due to E positive anyway. E positive along the opposite to that of dipole direction, or parallel or anti-parallel to the dipole direction. Now due to negative, it's of the same magnitude, but it's going to be negative or positive, same direction, does not matter. So one thing that we can do right now is, first of all, we define this as R, this as also R, and what is the, you know, like if I'm just going to talk about E, let me do a thing like this. Let me give it a name before resolving the components. The name of this electric field was just E. What's the magnitude of E? Due to one of the charges, it's K into Q divided by R square, and we know the value of R square. How much is it? It's going to be under root of X square plus L square. This is L. Okay, let's just keep that point in mind. Next thing, what is this? I'm going to call this an angle theta, this angle as an theta. What this should be, what this component should be, this component should be sin theta component, right? That's it. End of the story. So basically, if I'm going to define this as theta, it should be both 2e sin theta in the opposite of the dipole direction. So what is the net electric field, students? Net electric field, or let's keep it as electric field at point A, is 2 into K into Q divided by how much? X square. Okay, instead of X square plus L square, I'm just going to keep it as R square. Later on, you'll understand the importance of that. I mean, nothing, it's basically approximation. So I'll come to that conclusion later. But let's now 2 into k into q divided by, again I'm writing down as x square. Okay, just let me quickly change it. R square into sine theta. Now here comes the catch. What is sine theta? Sine theta, can you have a look at this triangle? We have a L over here. This is the theta. This is the R. This is a right angle triangle. What is the sine theta? Sine theta should be L by R. If you just substitute that value, what do you get? Let's first of all do and substitute the value and then simplify things. 2 into k into q into L divided by R cube. Simple. Let's move on. Okay, we no longer need to do all of that, things. You probably understood everything, I'm guessing so. And a very important thing that I forgot to mention, this is an electric field, this is a vector, and it should be minus p cap direction. Okay, this all should be in the minus p cap direction. Now let's write down this equation. Instead of that, I'm going to say that this is k into 2 into q into L. Okay, instead of k, it was written as q. Let me quickly change that. And this should be k divided by R cube into p cap. Minus or plus? Minus p cap. It was minus p cap, opposite direction to that of p. That is it, guys. Now we have moved into the game very easily, and this is what this 2kq into L is p. So this is going to be minus of k into p cap, which is going to be ultimately be written as like p vector p. Now let me come to this point. R is how much? Under root of x square plus L square. Can we say something like this? R square or R cube, for that sake, is approximately equal to x cube, because x square is added to L square and x is greater than that of L. That means R is approximately is equal to x. That means R cube is approximately equal to x cube. If you further simplify this, this is going to look like k into p vector p, dipole moment vector p, divided by R cube. End of the story. That's it. So the interesting conclusion is, on the dipole axis, okay, I'm writing down the term again, note down this thing. On the dipole axis, it was in the direction of dipole moment, whereas in the equatorial axis, on the equatorial axis, it is opposite to that of dipole star. That's it. That is it. It's a very simple one, guys. Very, 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 very simple one. If we graph it, it would look even more interesting. But what you're going to do is another important thing. This is on equatorial axis. There was a 2. Don't forget the 2 on the dipole axis. Just don't memorize it as k into p divided by x cube. Just throw a negative for equatorial and a positive for dipole axis, along with the positive for, don't forget that 2. Alright, and with this, let's do one more thing. I want to calculate maybe like electric potential at this point. What is the net potential at this point? What do you think it's going to be? Negative or positive? Negative or positive? So both of them are at distance r and r. I guess some of you already have that answer in mind. So V net or V dipole is going to be V positive plus that of V negative. V negative plus that of V positive. This should be a much, let me give the color appropriately, at least for the respective symbols. This should be how much? For the negative, minus of k cube by r, and for the positive it is plus of k cube by r. This should be 0. B of dipole on the equatorial axis is 0. Potential on any point for any x on the equatorial axis is going to be 0. If you take, like even a plane, it's going to be 0. It's going to r. As long as the distance between the negative and the positive charge is the same, it's going to be 0. So if you pass a plane in, like any kind of direction that you want, in any shape that you want, it's going to have 0 potential on. Right? So that's an interesting point. Note. Alright guys, that is it. That is the end of the dipole story on the axis, on the equatorial axis, on the dipole axis. But what about if it is at a point A, which is at a distance x, but this distance x is such that it is inclined at certain angle to the dipole moment? Think in terms of vector, try it out. It's a non-axis point. The magnitude of electric field at a non-axis point due to the shown dipole system, which is at a distance x from the dipole. Start working around it. Let me do a small thing before that. Just conclude few things around for this equatorial axis. One is potential is 0, and we have electric field at a point A. It's going to be what? Minus of KQP divided by XQ. This is for equatorial axis. To draw the graph, you will be getting like a graph like this. Okay. Alright. It's basically because it's opposite to the direction of electric field. Dipole is going to be in this direction. Or dipole moment is going to be in this direction, and electric field is going to be in this direction. That is the end of the story. But why don't you get started on this problem? Try it out yourself. Just get started on this. Think about it in terms of dipole system. Whatever we have calculated and derived, based on that, solve this problem. It's a simple one. It's a very simple one, but you need to make use of the things that we have learned until now. Try it out. This is actually a very interesting problem. Let me tell you, you need to work with vectors. And what is that vector we have over here? only one vector which travels from negative to positive, dipole moment. Okay, dipole moment is the vector that we know. So let me do a thing. You know what? I'm going to resolve this dipole moment. Okay, resolve this dipole moment. So that is the thing that you need to do, guys. Try to understand that point. It's a very simple one, but given that, you apply that simple thing. So this is your dipole moment direction. It's not probably visible, it's on the axis. So on the dipole axis, or the separation between them, if I am going to resolve the components, along which direction am I going to do it? Along this direction and perpendicular to this direction. Perpendicular to this direction, dipole moment is something going to be like this. But what is this value? And like in the axis of that x, it's going to be something like this. Isn't it? If you understood this point, it's a simple one. Right? So let's do a thing. Instead of let's call this angle as theta. Okay. Why am I not calling this angle as theta? I'm calling this angle as theta because this is the angle that is formed by this axis. Okay, one component would be perpendicular to this axis, and the other one would be parallel to the axis. Okay. Alright, just a moment. I'm thinking if we go this approach, it's a little easier to understand than this one, because resolving becomes a real challenge in this case. So just a minute. If I do this, easier for you. But anyway, okay. Let me do a thing. Instead of let me first of all explain you in this way, and then we'll move to this way. Okay, because this has become a little complicated, but I can do a thing for you. What we do is we keep a positive over here before we move to that problem. Let's do a thing. We are assessing everything in the dipole's direction, so just be cautious about it, and a negative over here. Okay. So if you understand this is also very easy. But anyway, our problem is given in that fashion, so we should be working around that way. But let's do a thing. Let me quickly draw a point which is at an angle theta with the dipole axis and center. Now in this case, dipole's direction is like this. It's pretty easy to understand, right? If I'm going to resolve the components, one component along the axis is going to be something like this, or in the axis is going to be something like this, which is going to be like P of cos theta, and the one perpendicular to this is going to be P of theta. Okay, if this is clear, that is also easy, right? Because I was going to write down, but I thought, some of you might get the confusion, and so I changed a little bit. If I do this is the theta in this case, don't forget it. We are assessing everything. Why did I do this? Again, let me come to this point. Because dipole's direction is like this. Dipole moment's direction is like this. Here it's like this, right? Good, Devara. Good, Varun. Good. So this is also, the perpendicular one is, P of sine theta. So don't get confused. in this case, okay, where theta is this instead of that. All right, and this is going to be P of cos theta. This is just a resolving point, guys. If you understood this, this is fine. Just substitute the value of theta as your 120 degrees rather. That's it. Okay. All right. This would become clear. Don't worry about it. You can think about it. Okay, let's not move into trigonometry. So our theta is this. Not 60 degrees, but rather 120 degrees. Okay, but anyway, before this, let's do a small work that is going to be understanding how to solve this problem in a simpler manner. So let's say I have a positive Q charge and a negative Q charge. Let me take it in the opposite direction if there is any confusion about it. So let's do a thing. We have a point at a distance from the axis. Now this is okay, whatever. Take a straight line. This looks horrible. Just a moment, guys. So this is something like this. Now let's do a thing. Let's resolve the components and write it down. Okay, given this is theta, this should be what? Sin theta. This should be what? Cos theta, and sin theta. Okay, this is P vector sin theta. This is what? P vector cos theta. But the direction of P is not the same. This is going to be having some, P perpendicular cap, and this is going to be like P we have just rotated this axis. Maybe we'll call this temporarily as something like an X dash cap and Y dash cap. Just try to focus. It's a simple one. Now the thing is, what I'm going to do is, first of all, let's do a small thing. Anyway, but these two components are perpendicular to each other. So I've just said that the axis has been rotated, and this is the X cap, this is the Y cap. X cap, I'm taking it as X cap because it's a little easy to understand along the axis. Along the axis of the dipole, okay, along the axis of the dipole, that is P cos theta component, which is along the axis, dipole axis, I mean, okay, generally axis here I mean is dipole axis, but let me change it. What is the electric field? Electric field is along dipole moment direction. If I'm going to define something like an X cap dash direction, it's going to be in the X cap dash direction. Okay, along with a 2k P or P cos theta. It should be P cos theta divided by the x cube. Distance is x cube. Okay, sorry, distance is x, hence there will be an x cube. X cap dash. Now let's come to the next point. Okay, so if you're talking about the perpendicular one, so it's in the direction, that's why x cap dash. Okay, if you're talking about the perpendicular one, what is the dipole's direction? Y dash, Y cap dash. And what is the component? It is P sin theta. Which axis it is? Equatorial axis. And what should be the electric field? let me do a thing. I'm going to name this as E parallel, then this would become E perpendicular. This is going to be K into P sine theta. K into P sine theta divided by x cube. There would not be a 2, and y cap dash negative. Don't forget the negative sign. If dipole moment direction was like this, electric field direction was supposed to be like this on a point on the equatorial axis. It's an equatorial axis for the P sine theta y dash component. Okay, P sine theta y dash component, and for the P cos theta x cap dash component, it's on the axis. If you understood this, we can say that electric field net at a non-axis point, okay, A is how much? Minus of, or let's start with the plus of 2k P cos theta divided by x cube into x cap dash minus of k into P sine theta x cube of y cap dash. This is exactly with the direction for a point on a non-axis point, for a non-axis point from the dipole. Easy? This is easy, guys. But you need to understand what have we done. We haven't done anything other than resolving which one? Resolving the dipole moment. We have resolved what? The dipole moment, not any other vector quantity. I hope this is clear. With an tilted axis, etc. Okay, we'll do that, Pawan. Good question. So, is this the formula for... yeah, students, note it down. This is the formula for your thing. But you need to understand that x cap dash, y cap dash, you need to have that intuition. Okay, let me quickly brief you through this. Whenever you see a point on the dipole axis, what is the electric field going to be? 2k P cos theta divided by x cube. Sorry, in this case it's cos theta. Let me repeat it again. For any point on the axis, on the dipole axis at a distance x from the dipole center, what is the electric field? It's going to be 2kp divided by x cube into p cap. Whereas at a point on the equatorial axis, that is the perpendicular axis to the dipole axis passing through the dipole center, at a distance x from the dipole center, what is the electric field? It's going to be k into p divided by x cube into minus p cap. Okay, now you know these two things. Now, if it is at any point, how do you do this? You do it this way. You need to resolve the components first of all and understand how it works, and then write down the equation. Okay, that's the reason we have a very different kind of dipole moment, that I kept the positive on this side, negative on this side. Still I am giving you a generalized equation. The moment you substitute it, you will get it all like what you are noticing, you know. You need not worry about it. Okay. This is the equation that you want to remember, guys. This is the dipole moment electric field at any point on the non-axis point. Electric field as opposite to the dipole on the axial line. Axial line, you mean equatorial axis? Yes. But on the dipole axis, along the dipole, it's going to be in the dipole direction. Now, some of the students have asked this, so let's do a thing whether this works. If theta is 0, what it is? Let me do a thing. Let me quickly take another color and maybe we'll do this thing. If theta is 0, what does it mean? It lies on equatorial axis. Sorry, dipole axis. I'm sorry. It lies on the dipole axis. From this equation, what do you get? For dipole axis, what do you get? 2 into kp cos theta. Theta, how much is it? Cos theta is of 0 is how much, guys? 1 divided by x cube, and it's going to be in the dipole direction, x cap in this case. And substitute theta is equal to 90 degrees. I'm not talking about the next term for the dipole axis, because that is going to be 0, right? Sine of 0 is 0. And about equatorial point, what is the dipole going to be? Minus k into p divided by x cube into p cap. Just substitute theta is equal to 90 degrees. Cos of theta, cos of 90 is going to be 0. Sine of 90 is going to be 1. Sine of 90 is going to be 1. That is it. Simple. Really simple. This is the equation. You can still substitute them in your dipole equation and understood it. But it was necessary to move from the axis point, equatorial point, and then understand it, that you can resolve them. This is a very key and the fundamental concept for solving around dipole based problems. Okay, all right guys, you should have noted it down by now, I believe. If not, you can pause the video and note it down, or later you can watch it. You can ask the doubts now in the live, and do not forget to comment below for the AMA section. We are going to do this problem as well, don't worry about it. Just an information, there is going to be an AMA section on the 2nd of October, and you may as well want to participate. Okay, so don't think about this thing, like why does it look a little different? It's because 120 degrees, cos of 120 degrees, it's going to look like this, guys. It's going to be like cos of 120 is negative, right? Minus of x cap is what you're going to get, right? So if this is the x cap direction, you're going to get minus of x cap direction. Alright, this is anyway minus y cap direction, because this y is going to lie like something like this. Okay. Now this gives you a better understanding. This is y cap direction. This would be minus y cap direction. This x cap direction, this looks like this because we have resolved it from the figure. It looks like this because you know what? This is minus 1 by 2 in this case. Or like, theta is negative. Theta is larger than 90, sorry. Theta is larger than 90, that's why this on the axis point looks like this. Otherwise, it's the same equation. We are going to write down the same equation. Alright, so we have got the electric field equation, which is going to be just a moment. It's going to be something like this: 2kp cos theta x cap divided by x cube minus of kp cos theta by x cube, or sin theta by x cube, that of y cap. Now this has become really very easy for you. It's a simple one. So just take magnitude has been asked, so if you further simplify it, hi Deepak, hi. Take out kp by x cube as common. Both are perpendicular components. You can basically add the square of whatever is left over other than the common terms, and you are going to see something like 4 cos square theta plus of sin square theta, not minus, because minus exists over here. And this can be further simplified as, okay, we are just talking about magnitude, kp divided by x cube under root cos square plus sin square. It's going to be 1. This is going to be 3 cos square theta plus that of 1. That's it. Now substitute cos square theta's value to be 120 in this case, because magnitude is being asked, right? So I'm going to rewrite that term, don't worry about it. Electric field magnitude was Kp divided by x cube under root of what? We had 3 cos square theta plus 1. You can note it down still. Just substitute the value of cos theta. In this case, how much is cos of 120 degrees? Cos of 120 degrees is nothing but minus 1 by 2. So, but anyway, it's going to undergo a square, so it's going to become a positive and plus of 1. K into P divided by x cube, 3 by 4 plus 1 under root of 3 by 4 plus 1, it will be like 7 by 2. Okay, so electric field value would be how much? In this case, it is going to be Kp. This is the generalized equation, but maybe a little difficult to remember. You need to know how to resolve them. Okay, if it's easy to remember, well and good. By 2. This is what we have. Let's check out the final result. This should have been this. Okay, easy, pretty easy. So two components, always resolve them into two components and work around them. Whenever it's given on an axis point, remember it. For an equatorial point, remember it. For equatorial point should be in the opposite direction of the dipole moment. In the on the axis point, it should be in the direction of dipole moment. In the direction of dipole moment. And when you resolve it, move according to x cap dash and y cap. Easy. All right. So x cap dash, y cap dash, you can derive them if at all some axis is given to you. Just apply translation or rotation of the coordinates. Simple one, guys. Simple one. Let's move on to next problem. For now, the electric potential at a non-axis point due to the shown dipole system. Think about it carefully and come up with the answer. Okay. Think about that equation, think about the diagram that we did earlier. Just because it is 120 degrees is not going to, it's going to change some things, but it's not going to change everything. So think about it little carefully. Alright, I think it's time that we get started. Let me tell you, be it electric field or be it for your potential, resolve the components. Simplest thing that could be done is resolving the components, one along the perpendicular direction and one along the in the axis direction. Okay, and as you know, this is theta. Due to this diagram, it looks like this again. Let me show you that again. So due to this theta, it looks like this. Otherwise, it would be like one along this direction. Sorry, one along this direction and one along this direction. Okay, this is what? This is P cos theta component. This is what? P sin theta component. Okay. Now let me ask you a question. Where does this A lie? A lies nearer to, somehow you can get this idea, right? It's at a distance x tilted at an angle, something like 60 degrees over here in the given question. Generally, you need to work around the theta point. This lies closer to whom? Minus q. So the net potential in this case should be negative. But as such, you would not be doing this. You would be just resolving the components. For an example, how you should be working around it. Let's say you are given a plus q like this and a minus q like this. Okay, what you need to do? You need to simply find out this. Just a moment, guys. Okay, let's say it's at a point like this. It's going to be like this. This is the theta case, and this minus q to q. Okay, now in such cases, what you would be doing, you should be resolving the dipole components. Okay, this is P, and one would be like this, other would be like this. Okay, I'm doing this for something, you'll understand it. And this should be what? This should be P sine theta, this would be like P cos theta. Okay, x cap dash, okay, fine. And this is y cap dash, that is all fine. Now, if you remember the potential due to the sine theta component does not exist. So this component has no role in potential. Okay, let's call this as a perpendicular one. Due to perpendicular one, it's going to be 0. Due to this on the axis one, you'll be having some potential. And if you rather look at this picture, this would be more clear what it should be. Potential, if you remember the potential on a point on the axis, it's going to be what? In this case, it is V net is going to be how much? K into P divided by x square, right? But instead of P, you'll be writing P cos theta. Instead of P, you will be writing P cos theta. That is it. That is it. Divided by x square. Okay. Substitute the value of theta, you get the answer. That is that, right? I hope you understood that point. Due to the perpendicular component, potential is 0. We are going to add two scalar quantities. That's science. But due to the perpendicular component, no potential. Hence, we are only worried about the one that is on the axis of the point. Okay. Simply, we can say that due to this dipole system at a point A, potential at a point A is going to be how much? K into P into K into P cos theta. It's not 2, it's just K into P cos theta divided by x square. And how much is your theta? Your theta is 120 degrees. Just substitute the value of 120 degrees. It's going to be K into P divided by x square into that of cos 120 degrees. How much this is going to be? K into P minus cos 120 minus 1 by 2, right? So it's going to be minus 1 by 2. That's it. You got a negative potential, which is correct. Isn't it? Verify it. It's nearer or closer to your negative charge. Simple and easy. Okay. For any such point, you can simply note down the potential. Potential is going to be what? Due to the dipole, K into P cos theta divided by x square for a non-axis point. You can note down this equation, guys. That's it. But does not matter. Learn to resolve it. That will help you solve most of the problems. Probably you want to remember the fundamental one on the axis, on the equatorial axis one. That itself will give you a good understanding. If not, if you want to remember them, you can written down the equations. You can take a screenshot, or you can like write it down as your notes. That's better. That's the best thing to do in Electrostatics. You should be making your own notes. Alright students, I guess this should have been clear to you. If not, watch it again. It's a simple one. That being said, Ask Us Anything session is going to commence on 2nd of December at 9:30 p.m. with all of our JEE English team. Make sure you are commenting below so that you are able to get your questions. You are able to get answers to your question. We'll gather your questions. We'll get the answers to your questions at 9:30 p.m. on Ask Us Anything session. So by JEE English team, make sure you attend the session and you get answers to all of your queries. And that being said, students, Unacademy Combat is going to happen again on 6th of December. Don't miss it out, because it's not only going to be a rewarding experience but a worthwhile or a valuable experience for JEE aspirants. Students, you're going to compete at a national level on this gamified battle. And not only that, guys, it's all about your JEE preparation as well, right? So attend these events. They are competitive, they are gamified, they are made interesting for you, but at the same time it's also rewarding, and you can win hundreds of Amazon vouchers. You can be the one winning that MacBook Air, etc. So enroll today. Make sure you are enrolling today with Murli Live code and attending that event on 6th of December. Make sure you are killing this event, guys. And that being said, it is the best thing that you can do during that 6th of December. And that being said, our JEE team is also on Plus. We have started courses on electromagnetism, differential calculus, optics basics to advanced, and chemical kinematics. And for 2022 aspirants, do we have something? Yes, our team has everything for you, like graph sets, relations, redox and equivalent concepts, and mechanics. So guys, yes, that being said, our Unacademy team has started a Google batch for droppers for JEE Mains in 2021 starting from 20th of November. It has just been started on 20th of November. You can still attend it. And for class 11, we have micro classes which has commenced on 20th of November, conducted by some of our best faculty. And that being said, do not forget to share this video, guys, because sharing is caring. That's a different thing. But you know what, someone in need may get access to quality, full length and extensive content for the JEE preparation, that too in English, so that every one of you can understand it. So do share this video, do like this video, do click on that bell button and subscribe button. That's for you, so that you get timely notifications. But do share the video for others, and do like the video, and do help us spread this information that we have like a channel in English for your JEE preparation, with complete content, with the best educators. Like we have IITians, NITians, head of institutions on the team. And do remember, achieve your success not just by working hard but also by working smart. Why am I saying at the end of the electrostatics? Because it does not make sense in the beginning of the electrostatics, because electrostatics requires a little bit of hard work, putting your pen on the paper. And acquire knowledge and share it. Keep smiling, students. And that being said, if you don't have a Telegram app yet, just download it from Google Play Store and App Store, and click on to this link which is available in the description box below. And guys, you can also type in JEE_English. We are already on Telegram app. So once you get onto this channel, what you get live before time updates on every class that is being conducted on JEE English, or any class our team conducts on Unacademy Learning app. So that being said, this Sunday from 10 a.m. to 1 p.m. we'll be having a special class, again a free of cost special class on problems and PYQs on capacitors. Be sure to attend them. We have already completed A to Z of capacitors in 6 sessions, guys. So this theory part is complete. With model problems session, will be completing anything that is also left over or left behind. But that being said, Guys, these 6 sessions are very important. This electrostatics lectures are very important. You'll be able to score 3 questions: current, electricity, optics, and this is for 2021 aspirants. 2022 aspirants, you can start them right now, not at all a problem. Electrostatics is where you have to begin. If you complete capacitors, if you complete current and electricity along with electrostatics, and if you complete magnetism, if you think magnetism is a little tough, you can skip it. But if you complete this 4 chapters along with something like nuclear physics, you are going to probably along with nuclear physics, or maybe like modern physics, you're probably going to get to that point where you're able to attend more than 60-70% of the paper and score about 90%. So make sure students, problems and PYQ session on capacitors is going to be live on 10 a.m. and come and attend it all along with polls. Enjoy the session. Be sure to attend the A to Z capacitor sessions as well. And every session matters, every problem matters, everything is a model problem. So make sure you're attending it. It's available for free of cost. And that being said, units, dimensions and measurements, that is also a very good chapter for 2021 aspirants. Why this is the easiest topic for your JEE preparation. It's less time consuming and everything has been covered in just 5 back-to-back sessions. All you need to do is spend a day or 2 and you'll be able to score 1 mark in your JEE Mains and JEE Advanced, 4 plus 1. So make sure you're attending these sessions. This like 4 plus 1, because this is only about the 4 session. There is 1 model problem session as well. And guys, it's not only easy for your preparation, less time consuming for your preparation, also in your exam it's less time consuming and comes in that easy part. And in JEE Advanced and all, there would be like a combination of question. You might well be knowing that current and electricity question, but you need to understand error analysis. So everything has been covered in this 5 back-to-back session: units based question, dimension analysis, measurement based instruments like vernier calipers, screw gauge, along with least count analysis and error analysis. So be sure to attend them on your Unacademy learning app for free of cost. And guys, do not forget to download Unacademy learning app from your Google Play Store and App Store to attend these sessions. All you need to do is type in Unacademy on your Google Play Store App Store and click onto this link and click on this install button. And guys, let me tell you something amazing. Not only that, you'll be able to attend national level quizzes, Unacademy Combat, and get live notifications on these free of cost special classes once you follow me. And guys, this is the amazing thing about Unacademy learning app. It comes with so many free of cost sessions, free of cost things. And not only that, students, the thing is also, if you have an Unacademy subscription, you can attend classes from anywhere. And you can actually complete the program from anywhere. So what is an Unacademy subscription? An Unacademy subscription is a complete package for your JEE Mains and JEE Advanced preparation. In this package, you will attend daily interactive classes with the best educators across the nation. Not only that, you will undergo an extensive and intensive structured program where every 4th session is going to be a doubt clearing session for your JEE Mains and JEE Advanced preparation. And that too, you can attend classes in multiple languages or language of your preference from the best educators across the nation. And guys, this program is going to be super interesting because you will be attending test series that are national level. You'll be attending national level test series, and with this also comes mega quizzes and quizzes on each topic and dedicated doubt clearing session. That way you're able to maintain completeness. The best kind of tool, or the best kind of platform, or the best kind of program, or the best kind of class that you can have for your JEE Mains and JEE Advanced preparation. And if you can afford it, it's one of the best things that you can have for your JEE Mains and JEE Advanced preparation. So be sure to avail it on time. All you need to do is click on the left hand top corner extension bar, choose plus, and then choose IIT JEE as your goal. And guys, with this you will be ready for your both JEE Mains and JEE Advanced, and hit on this get subscription button. And students, once you hit on this get subscription button, it's 1 subscription, unlimited number of access. Yes, you can attend as many programs as you want. And students, this kind of program comes at a price of less than 2,100 per month. What do I mean by less than 2,100 per month? All you have to pay is 70 rupees a day for this 24-month package. which is typically meant for 8th, 9th, 10th and 11th class students. So apply Murli Live coupon to get to this price point and to get the best discount on your subscription purchase. Start early and enjoy your journey. It's a 2-year-long journey, but enjoy each and everything that you do. Do not hesitate to give those test series. And students, if you are looking for convenient payment options while purchasing an Unacademy subscription, we have pay in parts and no cost EMI, using which you don't have to pay all the fee at once. You can split your payments into multiple parts using our pay in parts option and no cost EMI. No interest on EMI purchases, easy monthly installments without any interest. That's the beauty of an Unacademy subscription. We also have traditional payment modes like debit card, credit card, UPI, etc. And students in long-term droppers and in 12th class, this is the program for you. You need to get the 12-month package, which is going to cost you less than 2,900, comes at a price of 2,888 only. What do we have for you? As you know, we have dedicated droppers batch, 1,000 plus live programs going on, 100 plus programs going on every week, national level test series for your practice, and more importantly, 6,000 and 7,000 plus materials for your JEE Mains and JEE Advanced preparation. And be sure to apply Murli Live coupon to get the best discount on your subscription purchase. So yes, that being said, students, choose the right kind of subscription. But that being said, if you are looking for one such subscription where you can get guidance, expert analysis, personal coaching from IITians and NITians, it's going to be Iconic subscription. Students, you notice two kind of subscription choices. One is going to be Plus, other is going to be Iconic. If you choose Iconic, you'll not only get to attend classes from the best educators across the nation on a structured programs and with live tests and quizzes, but more importantly, you will get personal coaching from the best educators across the nation and from IITians and NITians who can guide you exactly on the path you need to take. You will get their expert analysis, you will get a personal study planner, and students, this all comes at a price of only 50,400 if you move for a 12-month pack. And if you go for a 24-month pack, it's going to come at a price of 77,400. And how do you get to this price point? You need to apply Murli Live coupon. Be sure to apply Murli Live coupon to get instant best discounts on any of your subscription purchases. And yes, our JEE English team is available on an Unacademy subscription. Now take your JEE preparation to the next level with our personal coaching, with our guidelines, and with our IIT JEE workshop, with our study planner, and with our test analysis. Guys, this is like one of the best teams that you will have for your JEE preparation. We have IITians, NITians, and the head of institutions on this channel. And we are on Iconic subscription, so you can personally interact with us and get to know about the things. But that being said, be sure to avail it early before 30th of November, because it's going to be new prices from 30th of November. There is going to be a price hike, so make sure it's not getting hiked before you purchase. It's all at only right now 77,000, and you will be paying literally 25% more, around 1 lakh. So make sure you avail it before 30th of November and choose the right kind of subscription and choose the right kind of test series. Do attend the classes, do not miss out, try to maintain completeness. Take care, stay safe, bye bye. See you in the next class with more interesting concepts and also something special for you.